And okay. No one has their cameras on. I can't see everyone. I'm just like talking to a if folks want to turn their cameras on, that way I can like feel like I'm talking to you. Um, that would be great. Hi, Kevin. How are you? Here's what I'm gonna do. I'm gonna share my screen and we'll just get started. Um, okay. All right. So what we're going to do today is we're going to first to start off with a general overview of generative AI. I assume, though, that a lot of you all have some sense of how generative AI works. And then what we're going to do is we're going to go through some empirical work that I've done looking at how Gen AI can affect the legal landscape. So that's our basic plan for today. My plan is to talk for roughly 25 to 30 minutes and leave the rest of the time for Q&A. Is that about right, Kevin? Or would you prefer me to talk longer or shorter? I'm
That's
flexible.
perfect. Yeah, and I think given your flexibility, and I know we've got a lot of curious folks here, so I would encourage people who aren't dealing with health insurance claims to speak up and ask questions if it comes up, and otherwise put them into the chat, and I'll try to make sure we fit you in a timely and appropriate fashion.
As it happens, actually, my main area of substantive expertise is insurance. So even if you have health insurance questions, I'm happy to chat about
We'll save
it.
that
All
for
right.
the after show. Yeah.
Yeah, right. All right, so let's start off with just what is artificial intelligence. Again, I will assume that this audience is somewhat familiar with this, but artificial intelligence is a very broad category. Everyone sort of defines it differently. People defined it differently decades ago than they currently do now. But we can think very broadly about artificial intelligence being machines doing things that we have historically associated with human intelligence, right? Now, there's really two basic subcategories of AI. So there's what's known as symbolic AI and machine learning AI. And symbolic AI is essentially AI that is programmed to follow certain sort of specified rules that human programmers encode into software. And so you can really think of this as, some program where you put in some specific rules using code, and then the resulting program does something that you associate with human intelligence or that you might have historically associated with human intelligence, right? So you think about this as like, the bad guy in a video game, right? That like sort of, you try to hit and it's a computer playing a video game. It's acting in a manner that appears intelligent, but it's just following certain rules that programmers have put into the program to get the bad guy to hit you when it comes too close or spear you or whatever else. Now, machine learning AI is fundamentally different because with machine learning AI, what happens is not that some human comes in and says, follow these rules. Instead, we say, look, here are some goals, computer, and we want you, computer software, to figure out for yourself how to achieve those goals by processing lots and lots of data. Okay. And so machine learning AI, instead of having some pre-programmed rules, we give essentially goals and we say, computer, figure out how to achieve these goals with lots and lots of data that we're going to feed into you. Now, machine learning AI itself can be sort of subdivided into two. So until a few years ago, the main type of machine learning AI that was out there was sort of discriminative or predictive AI. So sort of the famous example of this might be you feed a computer a picture and you say, is this a picture of a cat or not? Is it a picture of, there's some like funny ones like cat or a muffin? There are various muffins that look like cats, and actually I think the muffins look like dogs, whatever it is. And it can sort of sort the things in. But you can also use this for lots of really sort of important methods, right? So insurers would use this to figure out predictions of claims. Employers might use this to predict whether or not you're going to be a good employee, and medical complexes might use this to figure out whether or not you're going to respond well to a particular treatment. Now, generative AI is a different type of machine learning AI. And what makes it different is that really its main goal is not about sort of predicting anything, at least in sort of the traditional sense, or putting things into categories. Instead, its main purpose is to produce output that appears to be the type of output that humans that are really historically was uniquely associated with humans. What does that mean? Well, what we're going to focus on really is generative AI that produces text, right? These are large language models. This is ChatGPT, right? Lunch GPT. That's what it's a type of generative AI, sometimes called an LLM, where what the model does is it produces lots of text. Now, in some ways, you can think about this as a really just, you could reorder this and put generative AI under here, because in order to do this, all the model is doing is really predicting text based on preceding text, but in a way, the output's so fundamentally different, I think it's helpful to distinguish these two. Of course, there are other types of generative AI out there that will produce art, that will produce now videos, so forth and so on. We're not going to focus on those simply because those are much less relevant for lawyers. Why? Because, of course, the role of lawyers is to produce text. At least that's one of the main roles of lawyers. And so LLMs are particularly useful in that regard. Now, how does it work, right? We're going to just do this at a very high level of generality because I don't think we need to really understand the detailed mechanics in order to understand the potential benefits of these tools. Okay, what happens is we start off with what's called a foundational model. And the foundational model in a lot of these LLMs is a neural network. You can think of a neural network as essentially an attempt to simulate via code the human brain. But really, the basic idea is there are all these different connections and they have these different weights. And they start off like really randomly, right? So you just put in input, you take text, you turn it into numbers through something called word vectorization. You put into the model, and then it spits out other things. And at first, basically, I think this is like billions and billions of things and produces sort of a random output. But what you do is that over time, you get from that model architecture certain results, and you use what's known as a training algorithm to adjust the parameters of the neural network to get the predictions better and better and better, right? So it starts off with word one. It's trying to predict the next word. It gives you gobbledygook. You say, no, that's not good. The next word's actually, if the text starts off with the girl, right? If it says the, whatever, the tree, you can say, no, it's actually the girl, and you sort of nudge it in that direction. And that training algorithm over time adjusts the neural network. Maybe it takes out, it changes the weights of different parameters inside of the model so that over time, the predictions get better and better and better. Okay, now there's a lot of detail here that I'm glossing over. One important element of the detail is after you've done that, these days, what you tend to also do is what's called reinforcement learning with human feedback, which is once the models start getting decent predictions, you then train it again with humans who rate different outcomes to get better and worse outcomes. It turns out this has been a very important development to get these models to work really well. Okay, great. So that's sort of step one. That is what LLMs are at a very high level of generality. That's how LLMs work. Okay, and so what you do is you put in a prompt and you get this great output. Now, one other thing I just want to make sure we understand in terms of how these models work is something called retrieval augmented generation, which is really becoming sort of, I think, standard and is very important for lawyers to understand. So with a basic LLM model, right, you ask it a question. I sort of think of this as like a Plinko board where there are different weights, right? So the Plinko board inside the neural network is this billion huge Plinko board, but it's sort of been weighted so you get certain results. But it's sort of, it will change every time, even though you'll tend to get certain results. But it's just giving you results based upon essentially the associations that were learned in its training phase. Well, with retrieval augmented generation, what you do is, in addition to giving a user prompt, you also use documents that are pulled up via the user prompt. So usually what will happen is you'll put in a user prompt. It will go to a search tool. This is like a Google. That will then go to a database. You can think about this as everything on the internet. Although in our case, it might be more helpful to think about this as case law or texts or statutes. That will then be pulled out. So you'll get some key documents plus the user prompt, and that is then fed into the neural network. Now, why do I bring this up? I bring this up because one of the things, and again, I'm not quite sure about, your level of background, but I assume most of you have heard about the fact that these LLMs hallucinate, right? And there's the very famous case now. I think it's sort of become, ubiquitous of these lawyers who have relied on ChatGPT to produce briefs, and it completely fabricated the results. It produced, completely made up cases, and that can happen. Those hallucinations, right? Because it's just a Plinko board. At the end of the day, that Plinko board tends to produce sort of random results, and sometimes they're accurate, sometimes not. But it turns out that this technique of what's called retrieval augmented generation is much, much better, not 100%, but much, much better at avoiding hallucinations. Because when you provide both the key document and the user prompt, it is taking all of this as part of its input. And this is then predicting the next words based on that input. But as it turns out, it's dangerous to anthropomorphize these things, but in a sense, it acts as if it understands that you're providing it these documents. Okay, and it produces a result. So what can generative AI do? Here's one thing, I use this talk, I use these slides for something else, but you can see, you can produce this picture of a law professor giving a talk. It can produce funny poems, right? It can dangerously for higher ed summarize articles and produce essays. And I'm sure none of you have tried that, but actually this is a real problem for higher education and something we need to grapple with. And I can sort of illustrate that over here, right? But what we really want to start thinking about is what can generative AI do in the legal setting. And so I have done a bunch of work on this. There's, of course, a tremendous amount of hype on this, right? I mean, there are all these companies out there working on this. We, of course, have this lunch. We have all these professors working on this. We have all these lawyers working on this. But it turns out that there's actually not that much empirical evidence. And so one of my sort of research agendas over the last couple of years has been to try to actually get like empirical data about what can these tools do. And so early on in the sort of process, one of the very first things we did was we basically used ChatGPT, and this was the original version of ChatGPT that was released that relied on a model called GPT 3.5 to generate law school exams. And what we found was that, lo and behold, ChatGPT can produce a passing law school exam. Now, we did this sort of using blind grading, right? And at first, people were like, oh, well, that's sort of interesting, but it gets a C plus, like it's not, and it's sort of averaged in a C plus / B minus range, but it wasn't like, terribly impressive. It was like, that's not so bad. But more recent data has actually, of course, shown that these models are quickly improving, and where the rate of improvement seems to be greatest is in the legal domain. So what you can see over here is some data that shows GPT 3.5 and GPT-4. GPT-4 was released at this point, I want to say more than a year ago, which is hard to believe. And so there's a lot of talk that we're about to get GPT-5. And there are actually a ton of models now that are basically just as good as GPT-4 that are not produced by OpenAI. There's Claude, which is produced by Anthropic. There's a bunch of others. Google has Gemini, though they keep changing the name. It's hard to keep track of. But there are a bunch of models now that are basically as good. And this result over here was sort of hyped in the literature, but what you can basically see is, I need to move the screen over here, I have that at least by some estimates, GPT-4 passed the bar exam and did better than 90% of respondents. Okay. Now, there are some real risks of AI. And so this figure is drawn from one of my papers. And in this paper, what we tried to do was, instead of just saying, well, let's just basically throw a law school exam into ChatGPT, we said, you know what we should actually do is do something that's more akin to how lawyers are actually using these techniques. And so we did a study where we had students complete an exam using GPT-4 after they had completed the real exam in the class. And so what we were able to do was a different exam. So what we were able to do is say, okay, we have the student's real exam in the class, right? Maybe they got a B plus, whatever else. Then we basically gave them another test. We said, here, use GPT-4 however you want to help you produce a better exam, right? And this is the way that lawyers are supposed to be using these tools as a tool, not as a replacement. And what we found was that the way to read this is the percentile only unassisted task. You can basically think of this as, okay, what grade did students get in the class when they were not given access to GPT-4, when they were just sort of asked to? And you can see over here, right, some people didn't do terribly well. You know, a 0 is like a C or a D, right? A 50 a B, a 100 an A, right? And then over here, what we have is, okay, well, what happened when we gave them another exam? We said, well, look, use GPT-4 to help you. And what you see is that the students who did not perform well, just in the class in general, maybe we're getting B minuses or Bs or C pluses, whatever the curve was, I forget. They actually did a lot better. So you can see over here their improvement. This is their improvement. Okay, they improved a lot when we gave them GPT-4. Okay, so for the students who are not performing well, turns out this really helped them. But you can see that the returns on using AI generally went down as the baseline skill of the students went up. And what you can also see is at some point it crossed the 0 threshold, which means for the very high performing students, right? You can think of these as the students who got an A. Okay. And if you look at the students who got an A, they mostly perform much worse when given access to this tool than they performed without it. So this is, I think, really worth sort of pausing and thinking about. It's a very important result in my view. It's also, I should say, a result that has been replicated in other studies I've done in law, and also has been replicated in other settings as well. So we see this in there have been a variety of different, this is sort of a broad literature now evaluating GPT-4. Even though I like to think, you know, I'm at the cutting edge of this in the legal domain, there are a lot of people who are, you know, frankly, even more, not even more, much more empirically savvy than I am, who have done this in domains like, well, customer service and doctors and whatever else, accountants, science, asking, well, what happens when you give people access to generative AI tools? And again, generative AI. There are different results when you're looking at, say, predictive AI and you're giving them to doctors or whatever else. But with generative AI, what you tend to see is this result where for people who are newer, who are less experienced, who are less skilled, generative AI can be a very important tool that can improve their quality of their results. By contrast, there is increasing evidence that, you know, at the end of the day, it's not terribly helpful to more skilled people, particularly when they are doing more complex, difficult tasks. And in some cases, it can actually have the perverse effect of making things worse. Now, we can stop and say, well, why? Why would that be the result? I mean, surely if you give someone a tool, it can only make them better, right? Like, how can giving you a new great tool make you worse? And I think that there are, this is sort of still an area of active research, but I think that there are a number of important hypotheses that we have that are supported by more qualitative data rather than quantitative data. But there are a number of answers. So the first thing is, it is easy to see how when you use these tools, you can sometimes develop a less good understanding of the underlying material because you're relying on them, right? You fall asleep at the wheel. Why should I think hard about this thing? I can just plug it into GPT-4. So that's sort of the falling asleep at the wheel thing, right? It diminishes your incentive to take care because you have this tool that basically will do things for you. That's hypothesis one. I think we saw some of that. Hypothesis two is a little bit different and something else we saw evidence of in our data, though again, more qualitative evidence. And this evidence is it's not that so much that you care less. It's that what happens is that you get channeled into a certain direction that is different than the direction that really you would have gone in had you independently thought about it. One of the, I think, experiences of anyone who does a lot of writing, who is, and lawyers do a lot of writing, is that the writing is part of the thinking, right? And so a lot of times I don't really fully understand a problem until I write a lot about it. I sort of see assumptions I'm making, I see gaps, I see things. If you start out asking GPT-4 to produce a first draft and you try really hard, you've almost short-circuited that process. So I think that happens for some people as well. I think there are also just more prosaic reasons why this can happen. Another reason is it can be hard to sort of just piece together things that you've written with things that a machine has written, or things that a machine wrote in one answer to a prompt and things that a machine wrote in another answer to a prompt. And just like organizing your writing in a clear fashion is a really important thing for lawyers, right? I mean, writing is communicating. And if you're trying to piece together different things, some of which come from your own thinking, some of which come from prompt one, some of which come from prompt two, some of which come, it can turn out that you're going to get, lack of clarity in transitions. You're going to get lack of clarity in your organization. You're going to get repetition. You're going to get duplication. You're going to get omissions. And I think we saw that as well. Now, let me give you some other data. So this is from another study we did where we looked at the effect of providing GPT with access to GPT-4 versus having law students perform legal tasks where they did not have access. And note also over here that we saw a sort of pretty similar thing where the sort of overall mean, so you can look at the mean over here, this red is the mean with GPT, right? So this is how on average did students perform in, this was drafting a complaint. We had 4 tasks: drafting a complaint, drafting an employee handbook, drafting a contract, and drafting a client memo. And you can see over here that basically the improvements were very minimal on average. In one case, the AI was worse. This was in the memo. People on average did worse. And none of these differences are statistically significant. That being said, you can very much see the changes in distribution, right? So even though the means aren't changing, what you're seeing is in these blue humps over here and here in particular, that we had fewer very poorly performing students when we gave access to GPT-4. But we also tended to have, and you can most clearly see this over here, at least in some cases, scenarios where arguably GPT-4 was hurting. So bottom line right now, we need to be careful in terms of accuracy in how we use GPT-4, right? It's not necessarily going to help you. It might help you in certain tasks, but it might really hurt you. And it might really hurt you depending upon a number of factors. What's your baseline skill? What type of task are we dealing with, right? Some improvements in quality with some types of tasks, but less so with other types of tasks. What is the acceptable quality? I mean, sometimes you only need to do a job that's a B, right? I think about this all. One example I'll just give for me is when you're doing empirical work, you have to file something with the IRB, which is called the Institutional Review Board. And it's basically this form filling exercise. You have to write a lot of crap to bureaucrats who have to rubber stamp it. It does not need to be good. Like you don't get a grade for like great effort. GPT is fantastic for that, right? Like I don't have to deal with all that bullshit that I normally have to deal with. On the other hand, when it comes to like my scholarly work, I like to think I have high standards. I'm not just going to throw it into GPT-4. Now, given all this, you might say, well, gee, maybe I don't want to use GPT, this AI thing. I'm great. We all tend to think we're better than we are. And of course, over time, you're going to develop skills and there are risks. And why even use it? Well, that's where more data is useful. So this is the same study that was described in the last slide. Let me look at our timing. All right. I'm on a good track here. So same study. And in this study, what we did again was looked at these 4 tasks, but now we're not looking at quality as measured by grading. What we're looking at is time taken to completion. And what you're going to see here is that when you have, so here, lower is better, right? You want to take less time. And what you see here is that in all 4 of these settings, our students with access to GPT-4 just took much less time to complete the result. And so the reason to do this, even if you think of yourself as very skilled, is like, this can be a huge time saver. And we saw this consistently across results, and notably, at least in this stream, remember, for the most part, we were actually seeing in 3 out of the 4 scenarios, slight improvements in quality on average, or only very, very slight dip in average. So basic result over here is actually, what we found is, doesn't hurt on the quality, might help a little bit, and it helps a lot on the speed. Now, again, this is just one set of experiments, so 4 different tasks. But I think, again, this is very instructive in where AI can be incredibly useful. So a few things to say before we end over here and I go to questions. You might say, what do I take from all of this, right? And I'm showing you my empirical work. There's other empirical work that's out there. There's still not a ton. But in general, I think what we can take is, one thing we know is that these tools are getting better. Okay. And all of the research that I did was just focused on GPT-4. But it turns out that not only is, GPT-4 getting a lot better, maybe we'll have GPT-5 very soon. We already have a lot of models that are basically as good as GPT-4. Some people even say some of them are slightly better. But we know these models are going to be getting over time. But even more than that, none of this explicitly used retrieval augmented generation, right? And you'll remember I told you that's much better, much less risk of hallucination. And it turns out that there are a lot of reasons to think that that can work a lot better. So the way I would interpret these results is as a baseline, but not as an indicator of the potential for this tool to improve over time, and not even necessarily as what these tools can do now if you're looking at the right tools. And so I thought I would just illustrate this for you. I'm going to stop share for a sec because now I'm going to sign into I have access to a bunch of fancy tools that you may not normally have access to. And so I think it's helpful to look at this. So let's just start off with give me one sec to log into my fancy tools, and I'll try to show you a couple that maybe you haven't seen. I assume most of you have access to Lexis. But a lot of you might not have access to what I have. All right. Sec. Okay, here we go. All right, so I'm gonna share my screen again. So first, a lot of you have seen ChatGPT, right? This is ChatGPT. Now this is GPT-4. And one of the things, actually, a lot of mistakes people make is they think ChatGPT is the same thing as GPT-4, and it's not. So this is GPT-4. You have to pay $20 a month to get this. That's not a lot of money, but I know it can be an impediment. But what you can do over here is actually pretty impressive, right? So let's just, here's an article I was looking at earlier today. I was looking at, let's see if I can pull this up. Okay, here's the article. I was just looking at this article this is a law review article. It's so long. These law review articles are, look at this. This is crazy, right? It's I don't even know, 80 pages. It's super long, right? I'm like, I don't, I may, look, if it's important, I might need to read it. Okay. But I want to get a basic summary of it. And sure, I could read the abstract, I could read the intro, but I might miss things. So what do I do? Right? Let's see. Okay. Over here. What do I do? I can upload that document into GPT-4. I upload and I say, summarize the article for me. And you'll see over here, it summarizes the article. And then you can ask questions about it. You can, does the article, so this is real stuff I was doing earlier today, right? From a purpose of merit. Does the article actually evaluate how well, consumers actually understand the meaning of objectively clear contract text. Like that's what I wanted to figure out from this article, and it wasn't clear to me after doing the article, the intro. It says yes, right? And then I say, well, what specifically did the article find regarding that? And it tells me. Now, at some point it ran out, right? I like sort of wanted to actually get the information about the actual surveys, and like it was starting to give me it at a high level, but I wanted more detail, right? And it didn't really do a very good job. So then I went and I actually read the article, right? Because I realized, okay, like this is really an important article for what I'm working on, as it turns out. Maybe I'll come present that to you some other time. And this isn't going to be it. But what it did for me is it allowed me to see, gee, this is super important for me very quickly. And then I switched into like real mode, right? And I read the damn thing. But it might have been I got a different result. And I was very confident that these answers were right, because this is basically a form of retrieval augmented generation. Now, it's not in a sense, because all I did is it didn't do what I had described, where it does the search and pull this up. I gave it the relevant document, right? But now what you can see, so this is Co-Counsel, and this is, I would say probably the premier tool that's out there, right? And so again, I'll just show you, this is sort of a tool that costs thousands of dollars. I just get it for free because I'm lucky. And some of the law firms use, it tends to only be available at like fancy law firms. But here you can, let's see, let's see if I can pull this one up. Okay. So here you can see, and again, I'm just going to use things that are sort of in my domain of expertise, because I can actually evaluate better how good the results are. And where you can get into trouble is when you rely on this and you don't have the capacity to independently assess. So write me a legal memo for me in the application of contra pro forentum in Minnesota to sophisticated policyholders. Okay, it turns out that there's some complexities involved here. You'll note I'm specifying jurisdiction. I know that this is a difficult issue, right? So it sort of gives you this, says your results are ready. Do you want to see it? Sure. Let's view the results. Okay. So this is what it produced for me, right? It gives me an answer. Okay. It gives me an analysis with specific cases. And then what does it do? It has those specific cases, it summarizes them, and it lets me go to those cases. So this is using retrieval augmented generation, because what happened is I put in my request. What it did was it, behind the scenes, something that looks like this, right? It had a tool, it searched cases, it was linked to the cases, it automated what I did with that one article, fed in all of these different cases and my prompt, and it gave me an answer. And so the hallucination rate is going to be very low. And it turns out this is actually a really good answer. This is an accurate answer. And this is an answer that it could have taken an RA hours and hours to produce, and that was frankly probably better than what many RAs would do. So in other words, the results I gave you, they're the baseline. And in some domains, I do think that quality is going to improve dramatically as we get more retrieval augmented generation, more sophisticated base models, more models that are specific, right? So like Co-Counsel is particularly good for legal research. It is less of a transaction-oriented tool. And we can, where's my, let's see, my home. It's less of a transaction-oriented tool. Well, whatever. I'm trying to figure out where my, if I go to new chat. But it can do other things, right? It can summarize things. It can draft a contract. It can, but some of these tools are better than others. And there are just a ton of these tools out there. And so this is just one example. So I think that is everything that I want to say.